Okay, I'm going to do a few problems here that some students had questions on. And this says, 28 says, make and explain a prediction about the nature of the solution to the following system of equations, and then solve the system. So I'm looking at these two equations, and I know that I have a circle because I have x squared plus y squared. And I know that the radius of that's going to be 5 because whatever it's equal to, the radius of that is the square root of that. So then I have 4x plus 3y is equal to 0, and that's just a simple line. It's not in standard form or anything. It's not in, x-intercept form, but we will put it, not x-intercept, slope-intercept form. We'll put it there and figure these out. So illustrate with a graph, verify your solution, compare. Okay, so let's first just solve for these. First thing I'm going to do is put this into y equals, so what we would do is let's move 4x to the other side. So we would have 3y is equal to a negative 4x divided by negative 4. Nope, don't want to do that. We want to divide by 3, so we want y by itself. So y is equal to a negative 4x over 3. So now that we know y, we can plug that in for our equation of our circle. Let's do that over here. X squared plus a negative 4x over 3 squared is equal to 25. All right. So that's going to be x squared plus 16x squared over 9. That should be a 9 there because it's squared. Is equal to 25. So to get rid of this 9, I'm going to multiply everything by 9. Multiply this by 9. So that will leave me with 9x squared plus 16x squared is equal to let's just leave that right now as 25 times 9. Okay, so let's go with 9x squared. Well, if we combine those, 9x squared plus 16x squared, we get 25x squared is equal to 25 times 9. Okay, so if I divide by 25 here, divide by 25 here, that's going to leave me with x squared is equal to 9. Square root that, and x is going to be equal to plus or minus 3. Okay, so now we know what x is, and we know what y is. Okay, so what we're going to need to do is, we really don't know what y is yet, but now that we know what x's are, we can plug in for those and solve. So y is equal to a negative 4 times, we'll do the positive 3 first, and then y is equal to a negative 4 times a negative 3 over 3. Well, if we were to solve that, this would just simply be this would be 12 over 3, and this would be a negative 12 over 3. So when x is 3, y is negative 4. When x is negative 3, y is positive 4. Okay? Now, if I was to graph that, that means at 3, negative 4, and at negative 3, 4, my line, oh, that's pretty close. Try this one more time. So this is -3, 4. This is 3, -4. Okay, so that means my circle, because this is going to be 5, this will be 5. My circle is basically going to go through that as well. -5 and +5. If you were to graph that, that's what it would look like. Okay. Now it says derive an analytic equation for a parabola whose focus is 0, 4, and the directrix is the x-axis. Okay, so whenever we're talking about your equation here, 0, 4, that is your focus. Okay, so that's going to be your, let me just draw it here. So let's just go, I want to draw it over here. X is the directrix. Okay. The focus is at 0, 4. I'll scoot this over here. 0, 4. This is 4. Here's our 0, 4. Now, if that's a focus, that means our parabola is going to be a vertex right here of 0, 2. So let's write that as 0, 2 is our vertex, because we know the vertex form of a parabola. And that is equal to, since it's going up, we're going to have y is equal to 1/2 p times x minus h squared plus k. Now we know this is h and this is k, so we can plug that in. What is p? Well, p would be 4, right? The distance between the focus and the directrix, which is 0, which is our x-axis, it tells us that is 4. So just plug all of that in for p. That's 4. X minus h was 0 plus k. So that would be y is equal to 1/8. And then we will just have times x squared, because x minus 0 is x squared, plus 2. That's it. Okay. Remember these 4 formulas that you had. Page 2. Sketch the parabola from question 1. Okay, well, we already did that, right? We had 0, 4 is the focus. I'm going to write the F here. This is the directrix. The vertex is 0, 2. And it's going to look something like that. Not the best parabola. Let me try and do that a little bit better. Something like that. Remember, this is half of p, and this is half of p. So all of it is p there. Okay, 31 says solve the following system of equations or show that it does not have a real solution. Support your answer analytically and graphically. Okay, since they're both equal to y, let's just set those equal to each other. If we did that, that'd be x squared minus 4 is equal to a negative. I'm going to go ahead and distribute this negative here, negative x, distribute it here, minus 5. So I could put that as x squared plus x plus 1 if I moved 5 over here, move x to this side over here. That's equal to 0. Well, I cannot do trial and error, I know. So we would have to do the opposite of b plus or minus the square root of b squared minus 4ac over 2a. That's the quadratic formula, where this is the coefficient here is a, the coefficient here is b, and this is c. So the opposite of b would be -1. Remember, there's always a built-in there, always a 1 there. So -1 plus or minus the square root. B is 1 because it's, so that would be 1 minus 4. And A is 1, C is 1, so that's it there. And then 2A, where A is 1, so that's just 2. So right here it tells me that I have a negative inside the radical, and that's going to be an imaginary number, so we're not going to have any real solutions. We're going to have complex solutions. We already know about complex, but we have 0 real solutions because that negative inside the radical. So we would say no solution or no real solutions. And if I was to graph this, this just means looking at the, so I do have a parabola here. I have a parabola and a line. Well, the line has a negative slope and it passes through at a -5. And this will be a -5 as well. So it's going to look something like this. So your parabola, if we plug in 0 for x, we're going to have a y of -4, and that's going to be your vertex. If I plug in a 1 for x, I have 1 minus 3. Yeah, negative. If I plug in a -1, I have 1 minus 4, which is a -3. And if I plug in a +1, I have 1 minus 3, so it doesn't matter. That's what that's going to be. So let's plug in a, oh no, my fault. I did not do that correctly. That's not a -3. Let me do this again here. Okay, if I plug in a 1 for x, I get 1 -3. So 1 would be -3, and -1 would be -3. That's not the y. Okay. Now, if I plug in a 2, let's go to 2. This is -1, -2, 1, -2. If I plug in a -2, I get 0. If I plug in a +2, I get 0. So we can definitely tell that this parabola is going to look something like this, which means it's not going to touch. That's the reason why we have no real solution. All right, 32. 32 says, express the quantities below in A plus BI form. All right, so, and graph, okay. So, if we do 1, let's go ahead and do the distributive property here. Okay, this would be -1 plus I. So 1 minus 1 is 0. I plus I is 2I. So that'd be 0 plus 2I. Now if we do distributive property here, you should recognize these to be the difference of two squares, which means that gets rid of your middle term. So what is 1 times 1 is 1. I times -I is a negative I squared. Sorry, let me do negative I squared. Well, I squared we know is 1. I'm sorry, I squared is a -1. So we would have 1 minus a negative 1, which would be 2. Okay. So let's see down here. This will be a complicated one. Okay. This one's going to take a while. So let me go back up here to this one. Remember that I squared is equal to a negative 1. You always need to remember that. Okay, that's going to help you here. So let's do this one. This one's going to take a while. Okay, let's leave I out here. Let's not deal with I right now. Let's deal with these two binomials here. So that's going to be 2 plus 4i negative I negative 2i squared times I. Okay. So now we can combine like terms. That's going to be 2 plus 3i. Now this is going to be a negative 2 times a negative 1. So that's going to be 2 plus 3i plus 2. So that's actually equal to, I'm going to come over here with this, 4 plus 3i. But remember, we've got our I still out here. So if we do that times I, that's going to be 4i plus 3i squared. So that's going to end up being sorry, that's going to be 3 times negative 1 plus 4i. So that's actually going to be a negative 3 plus 4i. Okay, so this one's 2. So it'll be 2 plus 0i, so no i's there. Okay, so it's just going to be 2. And then did it want us to graph it? And graph it. Okay, so let's go over here. Well, 2i is going to be right here. That's our 0, 2i. Don't go anywhere. Remember, this is real. These are complex. Okay, so if we just had 2, that's going to be over here at 2, which is this one. And now where are we going to have negative 3 plus 4i? Well, that's going to be 1, 2, 3, negative 3. And then 4i is going to be all the way up here, 4i. So it would be all the way up here. Okay. Sorry I don't have much room there, but there's your 3 points. Maybe I can write those in a different color to make them stand out. Let's do red. All right, so here's negative. This is negative 3 plus 4i. This is just our 2i. And then this is just our 2. Okay. Now let's go back to our blue. It says use the discriminant. Now the discriminant is just what's inside the radical of our quadratic formula to predict the nature of the solutions here. So let's redo this as negative 3x squared plus 4x minus 10. I actually don't want to do that. Okay, I don't like that. But since we're doing the quadratic formula, it should be fine. So let's keep going. I'd rather have the x squared to be positive, but it shouldn't matter. So we're going to just inside the radical, that's what's the discriminant. So the square root of b squared minus 4ac. So let's do 4 squared minus 4 times negative 3 times a negative 10. Okay, so that's going to be 16 plus 12 times a negative 10. 16 minus 120. So that's going to be a negative inside this radical. Sorry, I need to put a radical here. That's a negative, which means we're going to have complex solutions. If we have a negative inside of the discriminant, we're going to have complex solutions. That's our prediction. Then it says solve. Okay, well, let's go ahead and do this. This is going to be a negative square root of a negative 104. So now if we do that, we're going to do the opposite of b plus or minus the square root of 104 over 2a, which is a negative 6. 2a is equal to negative 6. Opposite of b would be 4. Okay, so let's do that. We would have a 2/3 hold it. Let me take it back a step and do this all the way out for you. We would have a negative 4 plus or minus the square root of negative 104 over a negative 6. How can we break up a 104? 26 times 4? Yeah, that works. So we would break square root of a negative 104 would be 26 times 4. So let's call this the negative 26, which would be 2 square roots of a negative 26, which would be, we would write that as 26i. So 2 square roots of 26i. Okay. So now we have negative 4 plus or minus 2 square roots of 26i over a negative 6. So negative 4, let me jump all the way over here again, plus 2 square roots of 26i over a negative 6, and we would have negative 4 minus 2 square roots of 26 over I over 6, negative 6, so that's a 2/3 plus the square root of 26i over 3. And then we would have a negative, nope, that would be 2/3 minus square root of 26i over 3. Yep, there you go. All right, let's look at number, what's this? This is actually number 37 and 38, the last two that I'm going to do here. Okay, so this skips to number 37. It says a parabola is defined as a set of points in the plane that are equidistant from a fixed point called the focus of the parabola and a fixed line called the directrix of the parabola. So consider the parabola with a focus point of 1, 1, and the directrix, the horizontal line of y equals a negative 3. What are the coordinates of the parabola? Well, what we will do here is I'm going to go ahead and graph it in B and show you that the directrix. I'll show you the vertex here. So the directrix is negative 3. So it's down here. I'm just going to make it a straight, solid line here at negative 3. And it told us that the focus was 1, 1. And we know that the vertex is halfway in between the focus and the directrix, which would put it at 1, -1. So here we would say the vertex is 1, -1. Simple enough. Right? And so this is going to tell us to draw a sketch. Okay. So to draw the sketch, let's do this. We have the vertex. So let's do our formula. Y equals 1/2 P. It's going to go up. So that's going to be x minus h squared plus k. So 1/2 P is going to be 4. Let's be times 4. X minus h. This is h and k here. So that's going to be minus 1 squared plus a -1. So we're just going to leave that. We would say y is equal to 1 over 8 x minus 1 squared minus 1. And that's our formula. That's okay. We can do it. We can just leave it just like that. But now I want you to think, if I plug in a 0 for x, okay, if I plug in a 0 for x to get my y-intercept, okay, if I plug in a 0 for x, that's going to be 1/8 minus 1, which is 1/8 minus 8 over 8. So that's going to be a -7/8. So right here is going to be, let's just say that is that will be my, so it's going to look something like that. That's my y-intercept. So it's going to be a very wide plane there. Okay. Now, let's look at 38. 38 says, find the equation of the parabola with this focus and directrix. Oh, well, we've already done that. This is it. Oops. So we're going to have y is equal to 1/8 x minus 1 squared minus 1. That is our, what is the y-intercept? Well, I've already done that. I plugged in a 0. So let's actually do it right here again. Actually plugging it in though. Y is equal to 1/8 0 minus 1 squared minus 1. Well, that's going to be 1/8. -1 squared is still 1, so it's times 1. So we really don't care, because anything times 1 is whatever we're talking about. So that's 1/8 minus 8 over 8, and that's going to be a -7 over 8. That is our y-intercept. Now it says, demonstrate that your answer from part D is correct, which this is talking about, this is part D, by showing that the y-intercept you identified is indeed equidistant from the focus and the directrix. Remember, the definition of our parabola here is that it is defined as a set of points in the plane that are equidistant. So anything on this parabola right here, okay, anything right here has to be equidistant. Has to be the equidistance to here and to here. Okay, so we said -7/8. So let me go back to our blue here and work on this over here. Right. So the part of it's going to be easy. We know from the directrix to our y, right? We know that. We know that negative, so from here to here, we know that distance. That's going to be negative 7/8 minus a negative 3. We're just going to subtract those points. What's a negative 7/8 plus 3? That would equal 2 1/8. Okay, so that's going to be a distance of 2 1/8. Now, how are we going to come up with the distance between here and here, though? Well, we know the 2 points, so we can do the distance formula. And the distance formula is let's do x minus x1 minus x2 squared plus y1 minus y2 squared. All right. So what are our 2 points? Well, our 2 points is 1 and 1. That's our focus. And then our y-intercept is 0, negative 7/8. Okay. So the x of 1, which we'll call this 0, minus, here's this. This is x1, y1. This will be x2, y2. Okay. Plus y1 is going to be negative 7/8 minus 1. That's going to be squared as well. Okay. Well, negative 1 squared is going to be 1 plus negative 7/8 and negative 1 would be a negative, well, that would be 15 over, negative 15 over 8. And if we squared that, so it's plus 15 squared is 225, 8 squared is 64. Okay, so to add those together, I would have to have the square root of 64 over 64 plus 225 over 64 is going to equal the square root of 289 over 64, which is perfect. The square root of 289 is 17. Square root of 64 is 8. If we were to divide that, or we could take this and say 8 times 2 is 16 plus 1 is 17. So this is also equal to 17 over 8. Those are the equal distance.